Hey there, welcome to the whitchermath channel. Today we're just going to take it easy and talk about cookies and pie. Yep, just a food day today. Okay, cookies. Okay, sorry, we're actually going to do some math. This is a 7th grade standard, but believe me, this is not just a 7th grade standard. You need this your whole life. You need to know this, whether you're going on to college or depending on what your job is. You need to know this. And part of the standard is to give an informal derivation of the relationship between circumference and area of a circle. A lot of big words there. Importantly, what informal means is that it's not going to be a bunch of formulas, okay? Formulas are formal, okay? In fact, you can't spell formal without formula, or you can't spell formula without formal, right? There's the AL. So formulas are formal. This is not. This is informal. So basically, you got to find some way, not using formulas, to describe the relationship between the circumference, or the outside of a circle, and the area covered by the inside of the circle. So what better way to do that than with cookies? Hi guys, cookie collector here. Oh, yeah, okay, there we go. The cool thing about this is, if I screw up, we've got 2 of them. Okay, first of all, with my cookie, I'm going to find the diameter. Looks like it's 8. 8 centimeters is the diameter of my cookie. I prepared a little bit ahead of time here. Look at that. That is a paper version of my cookie. Bam, it fits right in there. If I was going to make a cookie cutter, I would just cut that out and forge it out of steel. Okay, so the diameter is 8 centimeters. And keeping that in mind, we know the radius is half of that, right? The radius is 4 centimeters, which leads me to this down here. Okay, these are radius squares. These are squares that I made out of the radius. Yeah, I hope that name makes sense to you. Meaning, I took the radius of 4 and literally made a square out of it. Now, when I find the area of a square, of course, you know how to do that. You just multiply 2 sides, right? So in this case, 4 times 4 is 16 centimeter squares. In other words, there's 16 square centimeters that fit in here. Okay? So square isn't just the name for an operation. It's literally the area of a square, something you're making. So the area of a square is never going to be 4 times 2. It's going to be 4 times 4, or whatever the side is. Anyway, you get my point. I've got radius squares here. Why did I make 4 of them? Because it takes 4, with a little left over, to cover my cookie. Okay? So I'm going to cut these out. Now remember, the whole time we're doing this, it might seem like a lot of fun, but we are doing this, right? We're informal. Have I used a formula yet? No. And we are showing the relationship between circumference and area. So obviously, first I'm doing the area. Now I'm going to take these 4 squares that are radius squares. That's very important to remember here. And I'm going to reorganize them in a different way. It's getting messy here. Okay, I got these 4 radius squares. 4 because that's how many it took to cover my cookie. Okay, now it's time to get the circumference. Like how I organize those? Yeah, nice, very organized. To get the circumference, you can't really do it with a ruler, and we could do it with a formula, but the thing is we're trying to be informal here. So right? I could pull a string around the cookie, which is very informal. Oh, there we go. That string represents the circumference. Okay? I'm getting hungry. I'm getting hungry now. So here's the thing. If I reorganize these guys and lay the string next to it, it's not really related, is it? Seemingly not related. But remember, back here, radius is half of the diameter, right? So assuming there's some kind of relationship here, or else the standard wouldn't have us do that, I'm going to fold my string in half. And I'm going to cut it in half. Okay? Ooh, now maybe we can get somewhere. This string now represents half of the circumference, right? So I had the circumference. I cut it in half. Okay, that's all I did. I've still got the circumference because I have two of them, right? Those cancel out. So just because I have two pieces of string, I still have the circumference. Now if I lay the strings next to the radius squares, look what happens. I've got 1, 2,
Good morning.
3.
Key communicators, please convene in the library.
That's me. I have to go to a meeting, so I better wrap this up. I've got 5 minutes to wrap it up. Okay, I've got half of the circumference here. I go 1, 2, 3, plus a little extra. Guess how much extra that is? Right. It's about 0.14 extra. Yeah, you got it. So if I cut my fourth area square, cut all that extra off of there, what I end up with is a rectangle. That one looks a little long because the end is frayed, but you got to trust me. This is precise. No, wait a minute. It's informal. So what I have here is a rectangle that represents the area of a circle. All right, here's a little bit of editing. So we're back at our rectangle, and what I want you to see here is this side. Remember how we find an area of a rectangle? Most people say, oh, that's length times width, right? It's a multiplication problem. So what's our length of this rectangle? Well, this is a radius, right? Each side of the square is a radius. So I've got a radius, another one, and plus a little extra. In fact, I've got pi times the radius equals that side of my rectangle. Okay, my rectangle, this side is pi times the radius. And then this side over here, maybe it's easier to see right here, right? This side is the radius. And so, to find the area of this rectangle, it's radius times pi times the radius, which is the same as saying radius times pi. So there you have it. We've used an informal derivation that connects the circumference of the circle, that's these two pieces of string, the circumference of the circle, and how it relates to the area. We converted the area of a circle to a big rectangle, and we just found the area of that rectangle. Bam! There we go. Now the best part, eat the cookie. Thanks for watching, and I'll see you later. Oh, yeah. Peanut butter.